So if you're given a graph and you want to match it up with the derivative, there are a couple of strategies that can be really helpful. One of the strategies is connected to something that we've already started in our last unit, okay? Or sorry, in our second unit. So I'm going to show you that strategy first. I'm going to show you that with number 4. With number 4, what we can do is we can look at the graph and we can mark the maximums and the minimums, because if you drew a tangent at a maximum or a minimum, it would be flat. And if you drew a tangent at a maximum or minimum and the tangent has a slope that's 0, we can go straight up or straight down from each of these points, and you know that those will be x-intercepts of your derivative graph, because the derivative finds the slope of the tangent and the slopes of all of those tangents, right? Anywhere I draw a tangent on a max or min, it's going to be a perfectly flat line. Those slopes are 0. So we can get those points. Sometimes that's enough to match, right? If you flip over the graph, you find which graph has those 3 points. There's probably only one of them. It's enough to match. But secondly, what you can do is remember that in our second unit, what we started to do is we started to make that number line for f of x, and you would have, it looks like 3, -1. I'm just making up these numbers. That's not necessarily what they are. But we have 3, -1, and 3. And as I draw my graph went down, then up, and down, then up. But the down and up and down and up told us something about the derivative. When we did it in the second chapter, or in our third unit, we plugged something into the derivative, found out, oh, when it's going down, my derivative was negative. When it was going up, my derivative was positive. Going down, it's negative. Up, it's positive. So that negative, positive tells me that here my graph has to be negative. Here, positive. Here, negative. Here, positive. And it gives us an idea where our derivative graph is positive and where it's negative. So by having those x-intercepts, you know you have to connect them together, and where it's positive and negative can really help us draw that graph as a result. Second strategy. Second strategy is if you look at the graph and you say, hey, I know that's a parabola. Okay, here we go. This sure looks like a parabola. What's a derivative of a parabola? If I have an x squared, the derivative will be 2x. So I have a line. Okay? So I know that this one needs to be a straight line. I also have a minimum here. It goes through that point. It's decreasing, negative here, increasing, positive there. I know this one needs to be a straight line from that. The one that we did at first on number 4. It's an x to the 4 graph. I know that I need to get an x to the 3 graph as a derivative. This looks like some sort of sine graph. I should get some sort of cos graph as a result. So what we can do when we're finding our derivatives is use the maximums and minimums, use the line, find out where it's increasing and decreasing. You could have done that for number 2 as well, right? You would have had 0 on your line. You know that your graph is going down and then up, so that means my derivative had to be negative and then positive. And those things can be really helpful for drawing the graph of the derivative. And on your test, it'll just be a matching question just like this. So these ones you can match with the ones on the back. And that will be all good. So for your test, on Monday, I would say, you've got your 2 quizzes. I've given you your pre-test. Did I also give you did I give you this review? Yeah. This review with the graphs as well? Okay. One thing on this review with the graphs as well, so that's review sheet, derivative laws, and quotient. Which question was it here? There's a couple. Okay, I'll let you work on that sheet. I'll find them. And then there's one that I wanted to. So the reason I wanted to do question 8 is I have one similar on the test, but it reviews something from grade 11. So I want to make sure that we review that together. Okay? That is really small. Let's see if I can make that bigger. So we've got a function, and what makes this question a little different is that it doesn't have all the numbers given to you. A is missing and B is missing. So A and B are numbers, but we don't know what they are. It tells us that it has a gradient of -6 at the point 1, -5. And then it asks us to find the gradient of the function when x is equal to -2. So it's a problem-solving question because it seems like we're not given enough information, and we also don't know what A and B are, which is going to cause us some problems. So what do we know? It tells us something about the gradient. The gradient is the slope. The slope of the tangent is -6 at 1, -5. And so that means I could find my derivative. Right here it's a power law. The 3 would come out in front. Subtract 1 from the exponent. Here the 2 would come out in front. Subtract 1 from the exponent. And having a gradient of -6 at the point 1, 5 tells me when x is equal to 1, g prime of 1 is equal to -6. I can plug this into that equation then and say I can plug in -6 for the derivative, and I can plug in 1 for x. And it gives me -6 equals 6a minus 6b. And the thing that's related to grade 11 is when there's 2 things you don't know in an equation, we don't know a and we don't know b, you will need 2 equations in order to solve for those 2 things. And in grade 11 you learn 2 different techniques. You learned a substitution technique and an elimination technique to solve for those. So we'll review that. Okay, so here I have got 1 equation with 2 things. I have to see, is there enough information in this question to give me another equation? And the answer is yes. We know, because we know the point 1, -5, what does that mean? In my original equation, when x is 1, y is -5. So in my original equation, I can replace the y with -5. I can replace the x with 1. And I would get 2a minus 3b has to equal -5. I now have 2 different equations with 2 variables. So when you have 2 equations with 2 variables, there's a couple of ways that you can solve it. One of them is called the substitution technique. You look at your equations and say, do I see a way to easily get one of my variables by itself? If I was doing the substitution technique, I would probably take equation 1. I would take equation 1, do it in black. I can get the 6a by itself by moving the 6b to the other side. I can get a by itself by dividing everything by 6. and I get A is equal to negative 1 plus B. That was the nicest equation to use because I noticed before I looked at both of them, I wouldn't have any fractions if I used that equation. It's not wrong if you use the other equation and add fractions, it just makes the work more tedious. Once you get one of them by itself, you take the other equation, and wherever the A is, you can now substitute that into the second equation. So my second equation was negative 5 equals 2 times A, and instead of writing A, I'm going to write negative 1 plus B minus 3B. Now I have an equation with just B. Having an equation with just B, I can just do the regular algebra, distribute this 2, combine my like terms, add the 2 to the other side, and you get B is equal to 3. I can now take that B is equal to 3 and substitute it into the equation where I had A all by itself, and I now know that A is equal to 2. It's not a bad thing to check after you're done. Do they work? Take equation 1, how it was irregularly. 6 times A would be 12. 6 times B would be 18. Minus 6 is 12. Equation 1 works. Plug the values into equation 2 to see if they work. B was 3, so this will be 9. A was 2. 4 minus 9 is negative 5. Equation 2 works. So now that we know equation 1 and equation 2 works, we can take the original question and rewrite it. We now know that the original g of x, I'll scroll up here so I can see it, it would now be 2 times 2, which would be 4x cubed minus 9x squared. Because I replaced the a with 2 and the b with 3. I also could take my derivative now. I could either redo my derivative or plug into here, and I will get 12x squared minus 18x as my derivative. What did this question originally ask us? It originally asked us to find the gradient of the function when x is negative 2. So it's asking for g prime at negative 2. I can plug in negative 2. I'm going to get 48 plus 36. And I'll get 84. So I have a question on your test that's similar to this, where you have an A and a B, and you're going to have to figure them out. It's been a while since some of you took grade 11 math. So that idea of when you have two things that you don't know, that you need to get two equations, and then either use substitution or elimination. Other things from both the pretest and the review. I think on the pretest, I had a question about a normal line. We didn't really talk about normal lines. So you can skip that if you want to do that. All a normal line is a line that's perpendicular to a tangent. So some of you have taken physics. You've done normal lines always perpendicular. So if you have your slope of your tangent, a perpendicular line slope is always the negative reciprocal. Remember that from grade 9 in perpendicular slope. So you take the slope. If the slope of a tangent was 1/3, the slope of the normal would be negative 3/1. The slope of the tangent was 4/5. The normal would be negative 5/4. But I don't have any normal questions. Sounds fun on your exam, on your test. They're all out. Okay, so I will let you work on those graphing ones for a little bit, and then we will do a little bit of notes